Hi, it's Alan from Crashtest Security. In this video, I will tell you more about the basic principles of DevSecOps automation and how they can help organizations secure their application workflows. So let's get started. DevSecOps is a modern approach to application delivery that implements security as a shared responsibility throughout application development, deployment, and operation. Given the distributed nature of modern applications, automation is considered key to the continuous integration of security analysis and threat mitigation of dynamic workflows. As an extension of DevOps principles, DevSecOps automation helps administer security controls throughout the development process. DevSecOps refers to the integration of security controls into the DevOps pipeline since the initial stages of an SDLC. The model promotes a culture where developers, operations, and security teams collaborate to ensure the enterprise delivers secure software. A DevSecOps practice helps organizations embrace a shift-left approach, where security tests and compliance checks are introduced earlier in the application lifecycle. Automation is at the heart of DevSecOps, with the security tools continuous monitoring and testing, allowing DevOps teams and security experts to focus on activities that enhance business sense. DevSecOps automation simplifies the integration of security approaches into continuous integration and deployment pipelines, reducing the number of errors that occur when security analysis is performed manually. Some guiding principles for automation in DevSecOps include: leverage container orchestration platforms. Containers offer unmatched abstraction and can be deployed across any development or production environment. Since each container runs an isolated instance, containers provide the optimum granularity to deploy security measures from the initial stages of a software development lifecycle. Container orchestration platforms, such as Kubernetes, simplify the deployment and management of containers, allowing for seamless collaboration between DevOps teams and security experts. Orchestration platforms offer deployment patterns with proposed architectures and components for securely designing and deploying cloud-native applications. Adopt a software bill of materials management approach. SBOM is an inventory of various third-party and open-source software components used within a codebase. Within an SBOM, security professionals can list all direct and transitive dependencies in the deployment pipeline, making it easier to identify security threats from third-party integrations. One of the primary purposes of an SBOM is to provide adequate granularity and visibility to deploy automated security tooling for continuous security monitoring and testing in modern applications. As an essential outcome, SBOM management tools relieve DevSecOps teams of the manual tasks involved in reviewing open-source software while helping with static code analysis of the software inventory. SBOM also includes additional valuable information for security analysis, including third-party licenses, software versions, and related patch status. Enforce application security testing. Application security testing involves repeatable security checks to automate the review and assessment of code security through continuous scanning. Static application security testing is a mechanism that helps analyze the software source code for security risks and misconfiguration, and is performed when the program is not running. Unlike SAST, dynamic application security testing is a black box security testing approach that does not require access to the source code. DAST is a front-end security analysis where security researchers simulate attacks to uncover potential security issues within the application. Through DAST, security teams can find runtime security issues, such as server configuration and authentication flaws, typically visible in a production environment. Other application security mechanisms used within a development pipeline include interactive application security testing and runtime application self-protections. Enable organization-wide training on secure coding practices. An effective way to mitigate potential issues in production is to ensure they don't exist in the code in the first place. To make security a shared responsibility between developers, security professionals, and the operations team, it is important to train every stakeholder on building secure applications. The security team should educate developers on secure coding practices that help them embrace a security-first approach to their daily tasks. Training should also include establishing communication channels for seamless collaboration between security professionals and developers. Organization-wide coaching also enforces stakeholders' accountability towards security, driving the crucial behavioral change needed to automate security controls. Implement threat modeling. When creating the DevSecOps automation platform, Security engineers should consider all the weaknesses in the system and how an attacker could exploit them. Threat modeling involves scanning the application through the eyes of a malicious actor. Continuous threat modeling helps security experts understand the application's security posture, which helps deploy the right security tooling for DevSecOps automation. Threat modeling acts as a blueprint for setting up a collaborative DevSecOps culture, as it helps each team better understand their roles and objectives in maintaining application and infrastructure security. Define security metrics. Security metrics enable key stakeholders of the application development lifecycle, including the operations team, developers, and security experts, to assess the intricacies of running applications in a safe environment. Optimally defined metrics help security engineers fine-tune remediation practices for accurate measurement and mitigation of cyber threats. Continuous monitoring tools also rely on metric data to track the performance and security of applications in real time. Security metrics are also commonly used to define service-level agreements, SLAs, and service-level objectives, SLOs, to help measure the performance of various software components of a tech stack. Developers rely on DevSecOps metrics for SAST, SCA, and the acceptance test processes before deploying source code into a continuous integration pipeline. Some commonly used metrics in DevSecOps automation include deployment frequency, mean time to repair, MTDR, uptime, downtime, patch cadence, vulnerability density, intrusion attempts and responses, third-party risk, security rating. Utilize infrastructure as code frameworks. Infrastructure as code enables the enforcement of cloud workload security by defining an entire security framework, including tools, protocols, and resources as machine-readable configuration files. The growth of SaaS and PaaS platforms over the public cloud has led to the development of production-ready configuration modules that can be deployed using coded manifests. Programmable infrastructure through code-based configuration files reduces the skill, expertise, and effort that tech companies are required to invest in securing cloud-native applications. ISC platforms also offer enhanced visibility of various hardware and software components within a CI/CD pipeline, simplifying monitoring and management for cloud security. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.